Okay, so welcome back to another video. Today's video is just a simple algebraic expression, and we want to compute the value / simplify it of the following expression. So we have the cube root of 4 subtract the cube root of 2 plus 1 quantity cube. So a lot of people will not think to use this method, but substitution is basically the trick on how to simplify this a little bit better. Obviously, if you're asked a question like this, of course someone's going to tell you to not use a calculator to find, compute the finite value, or I guess in this case what looks to be like an approximation. So substitution's the way to go. You just use that technique, and then solve your way just like using some algebra, and then eventually it just comes down to a simple expression where you could just plug that substitution back in to get the final finite value. So anyway, just that's all I want to say, so we can just jump ahead in. So I think it's worth noting that if you do put this in a calculator or some computer like Wolfram Alpha, for example, you're going to get the approximation specifically for this value is supposed to come down to 2.39 or 2.33928, and then there's more decimals, but I just stick with just a number of it. So let's suppose that we set the substitution. We'll call this u. So I'll let u equals the cube root of 2. And so in this case, we get the new, equation, or rather the expression. We can write this as u squared subtract u plus 1 and then cube. So what I can do is we can actually manipulate some things a little bit better for simplifying it even further for using algebra, that we can actually multiply and divide a u plus 1 cube to both the numerator and denominator. So let's see, So I'm just rewriting the same thing again, just from the left-hand side. Then we'll multiply a u plus 1 cube to both the numerator and the denominator, like so. Then what I can do here is, because they both share the same exponent, so we can actually combine this together as a product, then perform the necessary multiplication, and this is easy to show that you'll get that the inside quantity is supposed to equal to u cubed plus 1 and then cube. Then I can actually just expand this out. This is actually not that difficult to show as well. So it's u cubed plus 3u squared plus 3u plus 1. Then what I can do is I'll substitute u equals the cube root of 2. But I'm going to put that for our numerator over here, and I'll put this for the u cube over here. So we're just going to leave these variables the way it is, but we're just plugging into these two. So just from doing so let's see, we just perform this. So I'll just do 2 cube, add this with 1, then that's cube, and then divide by. So this is the same thing, 2, 3. I really don't need that parentheses right here, so I can just get rid of that. Okay. Then put plus 3u squared plus 3u and then plus 1, right? Okay, so that means we could just get the following. So over here, that's supposed to be a cube right here. All right, there we go. Then the cubes will just cancel each other out. So we're just left with 2 plus 1. So that will just be 3 cubed on the numerator. And then under the denominator, so we have 3 plus 3u squared, then plus 3u. What we can do here is that I can just factor out a 3, and so that'll cancel out one of the terms from the 3 in the numerator, so we just have 3 squared on the top. Then this is just u squared plus u plus 1, right? Do it again, the same thing, just like this method before, where we can multiply and divide just to get a 1. It'll still preserve the equality. So here, what I can do is we'll multiply to the top and bottom a u minus 1. So we have 3 squared, then multiply by u minus 1. Then over here, u squared plus u plus 1. Multiply with u subtract 1. Okay. Then what you can see is that, let's see, so I can just explicitly expand this out. So that'll just be 9 times u minus 1 then expand the denominator over here. Obviously you can see that this is just like necessary multiplication. This is u cubed subtract 1. And then the last thing we can do is just plug in the our u substitution back into over here. This is actually as simple as we can get. So here 9, then multiply with the cube root of 2, and subtract 1. Then this is this cube root of 2 cube, subtract 1. So that'll cancel each other out. Then you'll see that we have just so the denominator is just going to be a 2 minus 1, so it's just 1. And so that we have the final answer is just 9 times the cube root of 2, and then subtract 1 like so. And in other words, if you want to calculate this and put this in the calculator to see what the approximation is, it does indeed come down to the same number as above, 2.33928, just like that. And so there we have it, like just like that. Final answer, and I'll include the approximation over there like so. So here, that's another closed form to write this. It's not exactly in a form of just, numbers. It's in a closed form with finite, that with the closed form that it gives the same as the approximation over here. And so again, not a lot of people know about, I really shouldn't say not a lot of people, I guess it's not really taught in algebra. When you're trying to find the expressions like this, you would have to use substitution, because sometimes, expanding it out is going to get things too crazy. Not only just crazy, but it's just also, it can also be tedious too, depending on like what kind of numbers you're dealing with, real numbers, especially like for example is this. So and especially if you're being told not to ask, if you're being asked to solve or express the value without the use of a calculator or some sort of technology, yeah, that's going to be a bit of a challenge for you. So yeah, that's pretty cool if you ask me.